In this example, we're going to graph the linear inequality x plus y greater than 4. We'll determine which region to shade by writing the corresponding inequality in slope-intercept form and by checking one point. To determine which side to shade, there are two approaches that we can take, and so in this example, we're going to demonstrate both of them. Check with your instructor with regard to which one they prefer you use. To start, we have the linear inequality x plus y strictly greater than 4. We know that we're going to graph this line as a dashed line and then shade one side because we have that strict inequality. So, one way we could do this is to use the intercept method. Another way, which will be really helpful in that it'll tell us which side we need to shade, will be to solve this equation for slope-intercept form, because when we rewrite it in terms of y, it becomes clear which side we need to shade. So, we will first solve x plus y strictly greater than 4 for y. So taking x plus y strictly greater than 4, to get y on its own, I'm going to subtract x from each side, and that will make y greater than negative x plus 4. So now that I have that in slope-intercept form, I am going to graph the corresponding equation, which is y equals negative x plus 4, as a dashed line. Now the dashed line is helpful in that this inequality is strictly greater than negative x plus 4. So I need the line y equals negative x plus 4 as a separator, but I don't actually want it to be part of my graph because the points on that line will not be solutions to this linear inequality. So to graph this as a dashed line, I can note that the slope here will be negative 1, looking at the coefficient on x. So I'm going to write m as negative 1, and the y-intercept, now that it's in slope-intercept form, I can see it because I have negative x plus 4. The y-intercept will be the point 0, 4. So now I'll go over to my graph, and I'm going to label off my axes and scale them. And I'm going to make each unit, each tick mark worth 1 unit. So I'll label off 5 and 10 in this 10 by 10 grid, and negative 5 and negative 10. Now I'll use the point 0, 4. I'll graph that. And then the slope is negative 1. So I can think of m equals negative 1 as negative 1 over 1, or I can think of that as positive 1 over negative 1. I'm writing that two different ways so that I can go both directions to find more points on this line. Thinking of it as negative 1 over 1, I'll go down 1, right 1 unit to find more points on this line. And then I'll continue that, down 1, right 1, continuing on, doing that over and over. And then if I want to go the other direction, I could go up 1 unit, left 1 unit, thinking of that slope as 1 over negative 1. So up 1, left 1 from 0, 4, that puts me at negative 1, 5, up 1, left 1 again, I'll be at negative 2, 6, and then I'll continue on. So now I'll grab my ruler and I'll draw a dashed line going through these points. Now that I have my ruler lined up along these points, I'm going to put that dashed line in. And then I'll move my ruler out of the way and put arrows on the ends of that line. Okay, now that I have my separating line, I am going to determine which side to shade. Because I have this as y strictly greater than negative x plus 4, looking at where I've solved for this, so I have y strictly greater than negative x plus 4, I know that I need y values greater than this line. So I'm going to shade the region above this line. And so my next step will be shade the region above. Y equals negative x plus 4. And again, I know that it's above because of that strictly greater than sign. So I'll shade this region. And using my electronic pen, I'm going to get it as best I can. Pencil generally works better. Okay, So I have that region shaded. Now, at this point, I'm done. I have graphed, given a visual representation of all solutions to the linear inequality x plus y greater than 4. For this shade the region above part, I had to solve that original equation for y in order to do that. Another option, so an alternate, is to use a checkpoint. So shading the region above, I knew because of the strictly greater than sign. An alternate approach is to find a checkpoint. And when I find a checkpoint, I will choose one point, and if it satisfies that original inequality, I will shade that side. If it does not satisfy the original inequality, I will shade the other side. And again, so if it satisfies the inequality, I shade that side. If not, I will shade the other side. And I only need one point in order to determine this, because the separating line is where y equals negative x plus 4. So one side is the greater than side and one side is the less than side. So I'm going to choose, and I can pick any point. I'm going to choose, I see the point 1, 1 on one side of this line. So I'll choose 1, 1. And all that I will have to do is replace x and y in the original inequality with 1 and 1. So I'll have 1 plus 1, and I'm checking, is that greater than 4? So is 2 greater than 4? And the answer is no. So I would shade the other side. And as I can see from the shading I did before, indeed, I want to shade the other side that does not contain the point 1, 1. Let's do one more just to see. If we chose a point, let's say that we chose as our checkpoint, let's choose the point, let's pick 5, 0. That's on the other side. So I'll mark that off. And so I'm going to replace x with 5 and y with 0. So I'll have 5 plus 0. And I'm checking, is that greater than 4? And indeed, 5 is greater than 4. So I shade that side. I would shade the side containing the point 5, 0. So those last two checkpoints offer a different method for determining which side to shade. As we showed in the beginning, solving that inequality for y, we can just determine based on greater than, we would shade above, and less than, we would shade below. So those are the two methods you can do to determine which side to shade.